Hi everyone! Today we are going to be talking about measurement, specifically using rulers and meter sticks as well as graduated cylinders. The first thing I want to talk about is using a ruler or a meter stick. And I'm sure you're like, Miss Welsh, I've used a ruler before. I know what I'm doing, and I'm sure you do. And some of this may not be new to you. But just in case it is, this is why we're making the video, okay? So using a ruler, this is called the 3-5-7 rule. And this is when we are measuring something and whatever we are measuring doesn't exactly end up on a tick mark. All right, and what I mean by tick marks are the little marks or lines right here. I refer to them as ticks or tick marks. So that's what I'm talking about. So the 3-5-7 rule. So if I am measuring something and it ends up exactly on this one right here, okay, it would be 1.00, okay? And there are going to be some more examples in this video that will clarify what I am saying, but stick with me for now. So we're estimating an extra place whenever we are measuring, okay? So this ruler right here gives us our ones place, and it also gives us our tenths place with these little ticks in between the ones places, okay? So we are estimating the 100ths place. If these little ticks weren't here, we would be given the ones places, and we would be estimating the tenths place. But because these little ticks are here, we are estimating the 100ths place, okay? So we are estimating one more place than what our measurement tool gives us, okay? So like I said, this would be 1.00. Make sure there are 2 zeros because we are estimating the 100ths place. And the other number that is something that you've probably used before is the 5. So that is pretty straightforward. It's when it's right in the middle of 2 tick marks. So if we're right in the middle of these, the 0.2 and the 0.3 tick mark right here, we would say that this is 1.12, so 1.25, okay? We would estimate that 5. And then when the 3 and 7 come into play, that is when what we are measuring is either closer to the smaller number. So if it's closer to the 0.2 but not exactly on the 0.2 and not exactly halfway, we would say it is 1.23, okay? And that is the same for if it is closer to the 0.3 tick. We would say, and it's not exactly halfway, we would say it is 1.27. So if it's closer to the larger number, just estimate it as a 7. And if it's closer to the smaller number, estimate it as a 3, okay? We'll look at some more examples in a little bit that might make this make more sense. And also, it is okay that estimates can vary between people, okay? It's just based on your best judgment of where whatever we are measuring ends up with the tick marks, okay? I also just wanted to throw out there that using an older ruler, start at the 1-inch tick as opposed to the very end, because sometimes between the very end and the 1-inch tick isn't exactly an inch, okay? And I will clarify depending on what rulers and meter sticks we're using. I don't think we should run into that problem very often, but I will let you know. Okay, so like I said, we are estimating an extra place, okay? And so that also includes rounding. And I'm sure you've been rounding since you can remember, but I just wanted to include this. If it's 5 or larger, you round up. And if it's 4 or lower, you round down, okay? So like I said, in almost all of our measurements, we have to estimate the last number, and that includes the 3-5-7 rule and the rounding, okay? So for example, if I'm measuring something, if I measure a length of 3.57 centimeters, the number is only truly accurate to the tenths place, okay? The 7 in the 100ths place is my estimate. So that means that whatever I'm measuring ended closer to the larger tick, okay? And like I said, there will be more examples in the next slide. We estimate because we're reflecting how well that tool is able to measure the solid or liquid. This works for liquid too, or whatever you are actually measuring, okay? So this estimate reflects the tool being used. In this example, we were using a ruler, okay? If we're only given the inches, we'd be estimating to the tenths place. And there's an example of that in the next slide as well, okay? So here are the examples. So let's talk about this green box for a second, okay? So this measuring tool is only giving us inch ticks, okay? So we are only given the ones place for sure, okay? It's only truly accurate to the ones place. But we, like I said, are estimating an extra place, so we will be estimating the tenths place, okay? So I would say that this green box, it's obvious that it is between the 2 and the 3, so it is very accurate that it is 2 point something inches, okay? So I'd say that this green box is not exactly halfway. I'd say halfway is around right here. So I would use my 357 rule, and I would estimate that this box is 2.3 inches long, okay? And if your judgment says that this box is exactly halfway between the 2 and the 3, I don't think it is, but if you are dead set, then you would say that this is 2.5 inches, okay? But I'm going to go with that this is 2.3, okay? And it may look closer to 2.4, but we're using the 357 rule, okay? Okay, now let's take a look at this blue box. So this is giving us additional tick marks compared to the green box measurement tool. So it's between the 1 and the 2 centimeter, okay? So we are accurately saying that this is 1 in our ones place, okay? But this is also giving us the tenths place. So I'd say 1, 2, 3, 4, 5. I'd say it's between the 0.5 and the 0.6. So I can accurately say this is 1.5 blank centimeters. And that blank in that hundredths place is my estimate, okay? So I'm going to say that this is 2.57 centimeters, since this box ends closer to 2.6 than 2.55 in the middle, okay? So 2.57 centimeters is my estimate for this blue box, okay? So now let's look at this red box. So these ticks are going by tens, okay? So I can accurately say that the tens place is a 1, okay? Because this is between the 10 and the 20 centimeter marks, okay? And I would estimate that this red box is a little beyond the halfway point of the 10, between the 10 and 20 centimeters, okay? So when taking the 357 rule into account, I'd say this box is 17 centimeters, okay? Since it is not giving us the ticks in between, which would be the ones place, we are estimating the ones place, okay? So this is only truly accurate to the tens places, okay? So we are estimating the 1. So I would say that this red box is 17 centimeters. The 7 is what is being estimated, okay? And if any of these boxes were to be exactly on the line, the estimated digit would be 0, like we talked about, okay? So now let's look into liquids and using the graduated cylinders. So when it comes to graduated cylinders, we're going to read the volume from the lowest point of the meniscus, okay? And if you don't know what a meniscus is, it's this curve right here that is seen at the top of a liquid in response to its container, okay? It's its natural curve. So if I'm looking at this, I don't know, I know it's a little small, but this is exactly 48 milliliters, okay? So milliliters is what the unit that we will be using for graduated cylinders. Units are very important. We don't want any naked numbers, right? So we would say that this is 48 milliliters, okay? And the estimating tools, we just learned go for graduated cylinders. So here's an example of something that ends up in between tick marks for a graduated cylinder. So looking at this, this measuring device, or the graduated cylinder, is marked to the ones place, okay? So up here, this red box was marked to the tens place, okay? This is marked to the ones place because it is going up by 1, okay? So we would estimate an additional digit to the tens place, okay? So I can see that we can accurately measure this to be 15 milliliters, okay? Because it is between the 15 and the 16. And so now I need to use my 357 rule. And remember, I'm looking at the meniscus, not right here. I'm looking right here, okay? So I would say that this is 15.3 milliliters because I'd say it is a little less than halfway between the 15 and the 16 ticks. All right. Next, we're just going to talk about volume. I'm sure you've learned volume before, so I just want to do a quick overview of it. Volume is the three-dimensional space that something takes up, okay, and it's calculated by length times width times height for cubes and prisms. Something that's easy to get an accurate measurement. And then we will be using water displacement in our measurement lab. So if we are having some type of abnormally shaped object, such as a fish, it would be very hard to get the length times width times height for the fish. We would do water displacement. So especially if the item has round edges. So water displacement is the volume of the water plus the sample. So right here, so this is the water and the sample minus just the volume of the water, okay? And that is the volume of the sample, okay? Pretty straightforward. So you take the volume of the water in the sample, okay? And you take the measurement of just the water, and if you subtract the two, that should be the volume of the sample, all right? And yes, earlier, my puppy made an appearance. She doesn't like being left alone. This is Bella. I think she peeked her head up at the beginning of the video. So Bella has made her first appearance in chemistry. So we will be using all of these different little rules that we learned in our measurement lab this upcoming week. So if you have any questions, just feel free to email me, and I'll see you soon.